Welcome back, Physical Science 20. So here we have the FC1.4, the last section in the FC1 unit, the combustion of hydrocarbons. So look at combustion reactions, and again we're looking at hydrocarbons specifically. Represent them using equations, etc. Look at the difference between complete and incomplete combustion, and look at how incomplete combustions, how it has consequences for the environment and living things, and look at it from there. So the combustion of hydrocarbons in January 2005, 120 people who attended a hockey game at Vancouver Arena were treated in hospital for carbon monoxide poisoning. The source of the carbon monoxide was a faulty propane-powered ice resurfacing machine. So carbon monoxide is a toxic gas that can be produced during the combustion of a carbon-based fuel such as propane. Initial symptoms of carbon monoxide poisoning include drowsiness, impaired judgment, and unconsciousness. If we continue to get exposed, it could be fatal. Fortunately, everyone survived that incident. When we look at combustion, it's a chemical reaction in which fuel burns in the presence of oxygen, and usually that oxygen comes from the air. Coal, propane, gasoline are common fuels. The molecules of fuels, like compounds, are a source of chemical energy. So there's energy stored in the bonds. So energy stored in chemical bonds. That's what we mean by chemical energy. Combustion releases this chemical energy as thermal energy and light. Other products of combustion vary depending upon the type of fuel and how it was burned, how much oxygen was there. Common products are carbon dioxide, water, sometimes carbon monoxide. Carbon dioxide is a greenhouse gas, of course, that contributes to climate change, as does water vapor. Propane is an example of an organic compound, a molecular compound containing one or more carbon-carbon bonds. Many organic compounds also contain one or more carbon-hydrogen bonds. So if you look at what propane is, it has carbons linked up, 3 of them to be exact, and then hydrogens kind of linked up to the carbons on the exterior. That would have the formula C3, and then there's 8 hydrogens. So propane is C3H8, and each of these bonds contains energy which can be released. Many fuels contain impurities such as sulfur compounds and heavy metals. Combustion releases these substances into the atmosphere as air pollution unless they are removed by special technologies. Many substances burn. However, this section is dealing with a hydrocarbon combustion, and as the name suggests, it contains hydrogens and carbons, just like that propane that we saw on the previous page. So propane, C3H8, or lighter fluid, butane, C4H10, are common examples of hydrocarbons. Gasoline is a mixture of mostly liquid hydrocarbons. Most hydrocarbons are extracted from coal, oil, and natural gas. Although some hydrocarbons are used in the synthesis of other compounds, most are burned for their energy that they contain in those bonds. Much of this energy is used for transportation. Other important uses are generating electricity and home heating. So types of hydrocarbon combustion. Here we go. All hydrocarbons burn, provided they are hot enough and have sufficient oxygen available. We classify the combustion of hydrocarbons as either complete combustion or incomplete combustion, depending upon the product. So the two different forms of combustion do have different products. If you look at complete combustion first, the complete combustion of a hydrocarbon occurs when the oxygen supply is plentiful, so you have more than enough oxygen. The products are going to be energy, carbon dioxide, and water vapor. And the general unbalanced equation is this. So try to remember this. For a complete combustion, you're going to get CO2, H2O, and a lot of energy. And of course, to have combustion, your hydrocarbon has to be combined with O2. So if we look at, this general equation applies to all hydrocarbons. So if you look at methane combustion, CH4, so we're going to get CO2 formed, H2O formed, and energy. And then, of course, you just have to go back and balance it out. Okay. Complete combustion usually occurs under carefully controlled conditions with excess. So we have the excess means more than enough oxygen. Complete combustion is the ideal way to burn fuel because it releases the most energy. So it breaks those bonds and releases more energy than it would if it was incomplete. As a result, complete combustion produces clean, hot flames, less sooty. So the black smoke that you'd have in a campfire in your backyard is not complete combustion. That's incomplete. Now, this is supposed to be a colored picture, and that's a blue flame. A blue flame is one of the cleanest and hottest flames that you can have, and that's an indicator of complete combustion. So your orange flame that you have in a campfire or stove in the backyard, that is considered to be incomplete combustion. Keeping a natural gas furnace well maintained ensures that gas is burned as completely as possible and the products the most thermal energy. This helps reduce heating costs. Ethine, which is C2H2, is another well-known hydrocarbon fuel. It's more commonly known as acetylene, so acetylene torches. When ethine burns with a good supply of oxygen, it generates the high temperatures needed to cut steel. An acetylene torch is one that has two gas cylinders, one that contains the fuel and one that contains the oxygen. And the steel worker can control the temperature by adjusting how much oxygen is entering the reaction. So the flame can reach in excess of 3,500 degrees C, which is enough to cut through steel like a hot knife through butter. And there's the equation for an acetylene torch. So combined with oxygen, CO2, H2O, and of course we're assuming that is the complete combustion form. So let's do some of these. Let's take a look at, again, complete combustion. So ideal oxygens available. So let's take a look. So C2H6 gas plus O2 yields CO2 gas, and then another product is H2O vapor, and of course energy. So if we take a look at what we have here, so we have CHO, CHO, and CHO. So over here we have 2 carbons, 6 H's, and 2 O's. And on the right hand side we have 1 C, 2 H's, and 2 plus 1, 3 O's. So you can see here we're going to have to do a couple of things here. We're going to have to double the carbons first of all. That gives us 2, so we're good there. That's going to give us 4 plus 1, 5 oxygens. And then if we look at, we need 6 H's though, so we're going to have to make 6 here, groups of 2. I need 3 groups of 2 to make 6. And let's see, there's going to be 3 oxygens plus 4 oxygens, 7 oxygens. And then go over here. Now this is an issue here because we have an odd number of oxygens, and I know that if I put a 3 in front of here, that's going to give me 6 oxygens. If I put a 4 in front of here, that's going to give me 8 oxygens. So to get 7 in between 3 and 4, I'm going to need 3.5. Mathematically, that'll work. 2 times 3.5 is 7, so done. But yeah, we can't do that. We can't have 3.5 molecules of oxygen. So the little trick here, if you find that you get to the oxygens and you have an odd number here, and this is going to be true when you have an even number of carbons, we're going to have to double the coefficients. to balance the equation. So ideally 1, 3.5, 2, 3. So if I double that, so times 2, and this will happen all the time when we have an even number here. So 1 times 2, of course, is 2C2H6. Double 3.5. If I double 3.5, that's going to give me 7 O2s. Double this 2, that's 4. Double this is going to be 6. And energy, technically I'm doubling that if I knew what the number was. So if I take a look here, 2 times 2 is 4 C's, 4 C's. 2 times 6 is 12 H's. 6 times 2 is 12 H's. 14 O's, 8 plus 6, 14. Yeah, so that's going to happen when you have an even number for that hydrocarbon. Let's do the second example, propane. Every time you turn your propane tank on, what do we got going on? Now this is a mistake here. It says C3H9. It should be C3H8 as we looked at the structure on the previous page. So here's what I'm going to do. C3H8 plus O2. I'm going to get you to write down the products and see if you can balance it out. And then we'll take a look at the answer in the next video. All right, see you again.